Okay, guys, what's going on? Welcome back to our Learning to Program in C lessons. Sorry, it took me a little while to get another lesson out, but hopefully we should get into a rhythm here before too long. But we're going to be checking out today on lesson 3 is going to be on decision making. So how we are going to be able to make decisions in the programming language. So if we can decide what to do in certain situations. So in order to do that, the first thing we're going to be looking at is the good old if then else. There's actually a few different ways that we could look at it. I'm just going to highlight the three main ones. We've got if then else, we have the else if ladder, and we also have a switch case. All right, so basic operators that you can use in the if thens for decision making is going to be whether they are equal. You can check to see if things are equal, if they're not equal, if they're greater, lesser, greater or equal to, or lesser or equal to. And you can also do some bitwise stuff, meaning you can and an or thing. So you can do some decisions where if something is equal to something or it's equal to something else, then you can do things, or you can say equal to one thing and equal to another thing, then do something. So you got some flexibility with the different operators, okay? So we will get into how this all works once we start looking at the code. And for that, we're going to look at the syntax of the if then else. All right. So if then else has a syntax as such. So you've got the if expression. So let's show this here. Let me get a pen over here. So we've got the if and then your expression, whether, something's equal to something or whatever. And we'll take a look at that here in just a minute. You have curly brace open and a curly brace close. You have to have those because that way the compiler will know, where the beginning of the executed code, if this statement is true, will begin and where it will end. So basically what is happening is if, and then this statement is true, if that statement evaluates to true, or however you evaluate it, then it will run this code right here. So it's similar to like if you've done if-thens in Excel, maybe. If Excel has a similar thing, you can do an if, a number is greater than or equal to something or whatever. That's basically what you do. You can do this with variables and all different things. Then you have an else statement, which means if this is if this is false, then you can do something else. Okay. And then it follows the same structure, except it does not have an expression. It's just in all other cases, what do you do? Now, sometimes you can omit the else if you're just wanting to check on something real quick, to maybe update something and there really isn't something to do if this is false. You could just move on after you check. So you don't have to include the else, but if you're doing decisions where you want to check something and if that's true, then you do something. But if it's false or if it's the reverse of what you're doing, then you want to do something else. Or it could just be a catch-all as if it's this, then do something. If it's anything else, hence the word else, then we do it this way. So let's take a look and see what that is going to look like. So here is one of our quick programs that we're going to be running. We'll be going through this here in a minute, but we're going to say we do our normal include. I'm going to start using the void main, so that way I don't have to do returns. I will get into discussion about the difference between void and int and all that stuff when we start dealing with functions, but that's going to be in a later video. So now we've declared a number. We're going to print out how many siblings do you have? So how many brothers and sisters do you have? And we're going to read that in as a number from the user. All right. Now we're going to do a decision on this. We're going to check to see if the number that they enter into the variable number is greater than or equal to 2. If this is true, then we're going to print, wow, you have a lot, which maybe that isn't a lot, but I'm just saying. Otherwise, in any other case, if you put a negative number in, or if you put it in where you say that is a good size. Now, we'll get to how to check corner cases because obviously you could type in a negative number and it would tell you that that's a good size. But so there's some errors in it, but stick with me. We're doing basics. So we're going through the basics. So basically, if it's greater than or equal to 2, then we execute this code right here. If it's less than or equal to, or if it's, anything else, if it's greater than 2, if it's less than or whatever, it will say this is a good size. Okay. So let's go ahead and see that in actuality, shall we? So let's pull up the code here. All right. So we've got our void and we've got our our number and all of our different prints, and then there's our if. So let's go ahead and execute that and see what it looks like. As you can see, I've already compiled it. We compile with gcc-o for output, and then we give it the name of the executable, decision.exe, and decision.c as the input source file. Okay, so we hit that, and that compiled successfully. So let's go ahead and execute the decision. All right, so we're going to give that a moment. How many siblings do you have? Now, myself, I only have one sibling. So there we go. That is a good size. Now, going back to our deal, I only had one sibling, so that was not greater than or equal to 2, so it chose the else statement. All right. Now, let's see what happens if we do something with bigger. So let's say, like my kids would say they have 3 other siblings, all right, because I have 4 kids. So it would say, wow, you have a lot, because the 3 is greater than or equal to 2, right? So we're going to go here. So that's the basic decision tree. Now, all those other operators you could use ands and ors. You could put in, let's say, for instance, let's go ahead and do that real quick. If you put in, I'm just going to show you this as an example. It may not make, it's not going to make sense. But if the number is greater than 2, let's say greater than 6, and the number is less than, if it's greater than 6 but less than 12, then wow, you have a lot. Okay, that's what we're going to say. Let's make this look pretty. We'll write that out. We'll go ahead and recompile that. There we are. And then let's run it and see what happens. So if we put in something that is greater than 6 but less than 12, so let's say 10, it'll say, wow, you have a lot. See, because it'll be, yeah, it's greater than 6 and less than 10, right? Now, if I still put in, run it, and I put in, 1, it's going to say that's a good size, right? So that's how you do the, you add ands and stuff. And you can add as many of those as you want. I could come in here on this line right here. I don't know if you can see where I'm at, but this line right here, I could add something else. I could add another stipulation, or maybe even an or stipulation. I can add whatever and, give some code, and then do another and some code, and another or and some code. It's however you want to do it. Whoops. It's however you want to do it, right? So based on your decision making, that's how you code it to do it. All right. So let's go ahead and let's look at some other instances of it. So we went ahead and we checked out our if then else. So let's check out another version of that called the else if ladder. Okay. So the else if ladder, how it works is you basically do the same thing. It's an expression, but it's so you can have multiple expressions. Maybe you want to check for a bunch of different parameters. Maybe you want to check a bunch of sensors, or you want to check a bunch of different things. Then you can use the else if ladder. And this provides you an else statement, but with a condition still attached. So you can have if, and then your normal expression, if, Bob is 46 years old, do this. Otherwise, if Bob is 26 years old specifically, do this. If Bob is 18 years old, do this, and so on and so forth. And you can have as many else ifs as you want. And you can, again, either could keep or omit the else that's right here. Okay. So you could have basically, if none of this stuff is true, then do this, or you could have, if none of this is true, then it just continues on with your code, and you can leave this else off if you want to, but it is there as an option. So what does this look like in the actual code? So let's go ahead and check out an example here real quick. So in this example, we're going to read in how many siblings do you have, okay? And we're going to check to see if it's greater than or equal to 2, then we're going to say, well, you have a lot. If it's equal to 0, then we'll say you do not, so you are an only child. Okay. Then we're also going to check to see, is it between some numbers? Is the number greater than or equal to 10? And is it less than or equal to 20? So there we go. So there's your and statement. So that's a huge family, right? If it's in between 10 and 20, that's pretty good size. And then in all other cases, that is a good sized family. Now let's go ahead and see how this is going to work. So let's go ahead and bring back our deal here. So I believe I named this the ladder. So we're going to decision ladder. So let's look at it. So here we go. So there's our stuff. You know what? We could also tell them that they need to enter a different number if, or tell them that they had an incorrect entry. We could put in here, because I was just thinking of that. If you say else if the number is less than 0, then we want to, oops, let me put a space in that 0 over here. Got to stay pretty, guys. We got to stay pretty. So we're going to put our parentheses in, or our curly braces, excuse me. And then we're going to say printf, you did not enter a valid entry. There. So that way we take care of that corner case of if they enter negative numbers. Okay. So now let's go ahead and save that, and let's compile it. GCC-O. Helps if I can spell. And then we got the ladder.exe, and we've got the decision ladder.c. So let's let that compile, and then let's do that. All right. So let's fire it up here. So how many siblings do we have? Oh, let's say we do our, what's our cases that we have to look from? Let's see. Let's go back to our example here and back up one. What was our case? Oh, sorry, not back up, but what was our cases? So we had, if we had 0, then we should get you are an only child. So let's go ahead and check out the 0 case. Oops. 0, enter. So you're an only child. All right. Now let's check out the next one. Let's go ahead and fire it back up. So if we have greater than 10, but less than 20 or whatever was one of our other cases. So let's do 15. I'm going to say, wow, you have a lot. Then if we put in our negative number, -5, you did not enter a valid entry, right? And then for all other cases, so like 1, that's a good sized family. So there is an else if ladder for you. We checked out that if it's greater than 2, then wow, you have a lot. You're an only child if it's 0. And then if you're in between those numbers, then wow, you have a huge family. See? So that is an example of an else if ladder. All right, so let's move on to our third and final case, which is the switch case. Now, this is good for if you're doing, let's say, you have a specific thing. So like, let's say you got an ADC, an analog digital converter, or you have a certain thing that you're wanting to watch, and you're watching for certain things for it to report. So for instance, if you had, let's say, a sensor, and you had to run an ADC, so it was ADC, maybe it's a position sensor. And so you want to know, you're wanting to watch a variable that's recording the position, let's say, of something, and you're wanting to perform certain actions based on what position that sensor is in, or something like that. A switch case would be a great utility to use. It's basically like the else if ladder. It's just simplified a little bit. So how the syntax works, let's look at it. So you have switch, and then you give it a variable. Okay, so we're going to be watching this variable. And then when you say case in here, this case statement is meaning the variable. If the variable here, the case, if that variable is equal to a 1, see, and that's what we're saying, code to execute if n equals 1. See, if the variable equals 1, then it'll execute some code. And then we can say break. We can tell it to stop. The break command does a few different things in code. We'll see in the next video. In loops, it has a ability to stop a loop. But for right now, it basically breaks out of the switch case. It goes down to here and executes the rest of the code. Okay, is what we're going to do, is what it'll do after it gets done. So if it's equal to a 1, it executes some code and then stops. If it's equal to a 2, executes some code and stops, so on and so forth. And then, just like we have the else in an else if ladder, or even the if then else, you have a default, which means if this variable isn't equal to any of the cases that you define, then it defaults to some sort of code. And you could just put that in, just put a break statement in there. You could leave it out completely. It's however you want to do that. But a switch case is a little bit different. So let's go ahead and see what that looks like in practice, shall we? So we're going to go back into our lesson folder, and we are going to check out the decision switch. Okay. So here we go. We're going to ask how many siblings that you have, okay? And we're going to go through the basically if it's 0, you're an only child. If it's equal to 1, you have an average size family. If it's equal to 2, you have a good sized family. If it's equal to 3, you have a family of 6. And then default, you have a large family if it's more than 1, 2, or 3. We also could put in the negative case. So let's go ahead and do that as well. So let's right before our default, let's put in the negative case, shall we? So we do case, let's say -1. And we could say print F invalid entry. Now, I don't know if you noticed this, but do you see the flaw? A little bit of a flaw here. I kind of have to define it for every single case. I'm not really able to do like global comparisons. And that's because you, that I know of, you can't really do, or at least you don't really use a switch case for doing, the different modifiers, doing ors and ands and things like that. It's basically so you can just step through a few things and check a few things. So switch case is a quick and simple way of running through something and checking to see if something is equal to something. So let's go ahead and write that all out. So GCC-O, decisions, and then we have the switch case. Oops, helps if I type it right. So let's write decisions, switch, source, and then we're gonna do exe. So let's launch this bad boy. So how many siblings do you have? So if we have 0, you're an only child. If we have 1, average size family. If we have 2, we have a good size family. If we have 3, you have a family of 6. That's like mine. Woo! And then if we go even further, here, let me clear this out for us. If we go even further and we say we have like 10, then you have a large family. That's our default statement. And then, of course, if we do the -1, invalid entry, right? So that's basically how a switch case works. It's a very simple way of running through the different modifiers, just seeing if something is equal, seeing if this number is equal to certain cases. All right. So make sure you remember that we have the 3 different decision methods: the if-then, the if-then-else ladder, and the switch case. So I hope this video was helpful for you guys. Hopefully you guys learned quite a bit on this so far as decisions, and please try this out on your own. Stay tuned as well for more videos. We'll be going over loops in the next video of how to loop through things and stuff like that. We'll be getting more advanced topics coming soon as we get more of the basics down. So guys, thank you so much for watching. Thank you so much for being my patrons, and please share the Patreon page. Definitely let your friends and everybody know, especially those that need this information. This is like what you get in college courses that cost you hundreds of dollars, and here you get it exclusively as a patron member for a fraction of that cost. So definitely share this around, share around the Patreon. Please don't share the video, but share the patron page and let them know, so that way it helps out the channel, helps me to keep producing this great content. So thank you guys, and we will see you next time.